Hi, welcome. My name's Rob. I'd like to welcome you today to a little experiment I'm going to be doing here with the Elm programming language. So, let's start off with what is Elm, and then maybe we'll talk about what I'm planning to do. Of course we will. So, Elm, one of the best descriptions I have for this is right on the Elm language website. A delightful language for reliable web applications. Reliable web applications. That's actually very true. With Elm, it's a real functional language. The compiler's got your back. It's not like JavaScript. JavaScript's very nice. Written lots of Angular, lots of React, lots of everything. But it doesn't really have your back. It's very easy to shoot yourself in the foot. With Elm, the compiler's kind of got your back. It can be trickier to write your code in a functional way, but ultimately it's more reliable code. So that's why I want to play around with Elm. Now, next thing, what do we want to do? I had a couple ideas I wanted to exercise my Elm muscles with, but I was also playing with Pokemon. So I thought about something that would be actually useful to run on my phone. And here's what's up. So here's a mock-up of the kind of thing that I eventually want. I want to basically practice applying the skills of knowing what beats what in Pokemon Go. Right? So here's the idea. Your opponent is Psychic. Okay? Would you choose to counter with Poison? Would you choose to counter with a Bug type? Would you choose to counter with a Steel type Pokemon? So knowing these rules, important if you know the battles. Now there's a whole lot more actually. There's lots of permutations and combinations with Pokemon. But knowing this kind of thing, I think is kind of important. In fact, let's go over here. If you do a quick Google on Pokemon type effectiveness chart, you end up with a whole bunch of charts. And the one that I really like is this one here. So I'm going to click on this. There we go. Oh, Pinterest. There we go. So this is basically this is the kind of the simplest thing. If let's grab something we know about, water. Okay, we know that water puts out fire. Okay, so water, if something's a fire-based, you would use water to counter it. So water is strong against fire. It's also strong against ground, it erodes. It's also strong against rock. It erodes rock too. That's kind of what water does. Thinking about grass and electric types, it's actually weak against those. The thinking is, grass soaks up water. And maybe you can think of, water conducts electricity, so that's why, water is weak to these types and water is strong against these other types. And it's kind of neutral against anything else. So water versus psychic, water versus fighting, it's kind of a mix-up. So those are the skills that we want to remember. And that's what I'm planning to do in my little game. So let's go back to my mock-up of what I want to do. So I'm planning to present a page like this. We'll have a time limit, and you'll have to select the correct counter. And what I'm going to do for the three counters is one of them will be the one that it's strong against, one of them will be the one that it's weak against, and one of them will be one that it's neutral against. Okay? In fact, let's look up Psychic right now. Go back here. Psychic. Where is Psychic? Okay. Psychic apparently is strong against fighting and poison. So the correct answer when we go back to this page would be I should select this one. Oh, sorry, no, that would be the exact wrong answer. I'm trying to counter Psychic. Yeah, Psychic's my opponent. If I choose this, he'll defeat me. So actually what I would like to select is probably bug. There we go. So yeah, that's the idea. We're going to have something that'll help ingrain those rules. Obviously, I don't know those rules really well yet, but we're going to build a game that'll ingrain those rules. The idea is going to be we'll have some kind of a timer. Maybe it'll be 30, maybe it'll be 60. We'll see what feels right. And you'll get points for everything you choose correct. You'll get deductions if you choose the wrong thing, and I think we'll just say no score change if you're neutral. And maybe we'll tell you why your selection is good or not, just so we can build that mental model. So thinking about this, I'd like to say that, water puts out fire. Water erodes ground. Water also erodes rock. So maybe we can come up with some hints that'll help us remember those rules. Things like fire burns grass, or stuff like that. Anyway, so that's the plan. I hope you join me. Once again, this is a little mock-up that I built real quick. We're going to try to build this using the Elm programming language and have a fun little game. So let's give that a shot. Hope you join me. Thanks. Welcome back. Let's get started. So we want to build a simple web application in Elm, and then we'll kind of evolve it into our game. So let's start off by, I'll bring up a terminal window. By the way, everything we're doing here you can do on a PC or a Mac or Linux. It's all the same. It's very portable. So we're going to go into my projects directory, and we're going to say mkdir, and I'll call this PokeType. Yeah. No, I'll say PokeType. PokeType battle. Then I'm going to change into that directory, and I think I've already got two PokeTypes. I've got our mockup and a battle, so I'll just say battle. There we go. Now, next we want to create our Elm application. Let's actually go over to, I'm going to search for Elm again. There's a really great example in this elmprogramming.com. Very simple. Build a simple web page. Hey, that's exactly what we want to do. So I'm going to click on this link, and it runs you through how to do this. Basically, here's a traditional web page, that displays this. And if you want to build, if you want to do this in Elm, here's what you do. You would start off by using the elm init command to just create some very simple files that are needed for the Elm infrastructure. Then you could create your Elm source. So here's our Elm source. It's a home page. This is the source that will eventually, make that web page for us. Here's how we compile it. And then finally, we do need to have an index. We need to have, an actual HTML page that is the starting point for running this stuff. And in fact, so we can kind of see here how this works. I want to back up just a bit. This takes our Elm source and creates a JavaScript file called elm.js. And then this just, basically, hey, read in that elm.js code. And please run that for me. Please start that for me. That's how this works. Simple stuff. By the way, because of this pattern, you can do it to host an entire web page, or you could just have like a single component. So you can build parts of your web application using Elm, or you can build the whole thing. We're doing basically this exact thing here, which is we're just building a web page using Elm. So great starting point. Let's do it. Let's see, what do we want to do? We want to go over here, and I can open this in Visual Studio. Oh, we want to start with a command. Oh, actually, I'll open it up in Visual. No, I'll type it here. Elm init. I'm making it up as I go along. Yes, we want that. Then I'm going to open up this in Visual Studio Code. So it doesn't add a lot. That elm init command basically creates this JavaScript file that says, hey, here's Here's the libraries that are being used by Elm, etc., etc. All good. So what do we want to do next? We want to create that Elm file. Did I copy that yet? I'm going to go over here. I'm going to copy this to my clipboard. I'm going to go back to Visual Studio Code. Can I find code? There it is. I don't know what that error is. I'm just going to ignore it. Okay. Source, new file, home page .elm. Nice. So let's do a paste. By the way, I do have if you have something like Visual Studio Code, you will want to add the extension for Elm. That'll provide some nice, actually it's quite nice, it knows about the Elm syntax, and it's got your back once again, so we can get some nice information here. But I digress. Let's continue on. So we've got our Elm homepage. Next, we do know that we do need to have, I'm going to skip over this for a moment. We're going to go directly to the HTML file. So I know I need an HTML file just like this, right? And they're saying index.html. Yeah, I agree. Let's call it that. So if I go back to Visual Studio Code and we look at our files. Come on. Sorry, guys. What are we going to do? We are going to, I'm going to stick the HTML file into a dist subdirectory. So this is where I want to put all the distributable files. So the whole idea is going to be, the index HTML and the JavaScript file that we produce. Those both need to be distributed. So I'm going to create a dist directory here. Dist. And that's where I'm going to put in, we'll say new file, index HTML, and I'll just paste in that index HTML. Okay, so far so good. Now, if we open this up right now in the editor, it's not going to do much. And the reason why it's not going to do much is we don't actually have an elm.js yet. So it's basically going to be a big blank web page. Let's just confirm that. Opening my browser. Yeah. So far, not too much. So back to what we were doing. We're going to go back to code. The next thing we want to do is we want to compile this Elm project, and we want to produce a JavaScript elm.js file, and we want to stick it in the dist folder. So I'm going to now go back to my terminal, and we're going to use, it's pretty common for a web application to be using npm for doing a lot of the steps. So I'm going to use npm for this. So I'm going to go npm init, and it's saying, okay, we're going to accept a bunch of defaults. PokeType battle for the package name. Sounds good to me. Version 1. Yeah, looks like version 1. Description, I'll say fun little game built using Elm. Entry point. Now this is all kind of optional. Test command, get repository. We'll fill that in later. I will store this in Git though. Keywords, author. Yeah. Okay. So why did we do all that? Well, we did that to get a package.json. And now I'm going to add, let's see, what do I want to call this command? I'm going to call it build. I'm going to add a build command. And what's it going to do? It's going to run the Elm compiler. So going back here, we can just, it's going to be like this, but a little different. So I'm going to copy this. I'm going to go back to code. We'll just paste that in here. So this will be run in my root directory. Our source page is indeed source home Elm page. Our output is actually in the dist directory, and we want to create the elm.js file there. That looks good. Might as well fill in my name here. Doesn't make a difference, but all good. And for convenience, I'm going to bring up a terminal window. So that way you can see everything on the screen at once. Now, if I go npm run build, it should compile my source, which it did, and it actually stuck the elm.js file in our index directory. So let's open with, oops, that's not what I want to do. Actually, oh, I do have a shortcut in here, by the way. You may have to do this a different way. I can just go open in default browser, and it opens here. Lovely, very simple. Cool. So I'm going to vote that we call that kind of step 1. Now I'm looking at this. Yep. I'm thinking, let's initialize a repository. Publish to GitHub. Yes, let's create a repository. Okay, so now it's under Git control. And do I want to do all of this? Actually, I think we really want to check in source for the most part. So we're going to add a git ignore. So what do we want to ignore? Well, we don't want Git to be storing the Elm stuff directory. So we're trying to get that now. Yeah, it went from 18 to 6. That sounds about right. Now we don't technically need to store elm.js. I think I'm going to ignore that too. So I'm going to say dist elm.js. Don't check that one in either, because we just want the source here. And that looks pretty good. So let's do our first commit. We'll just say simple web app. Save and publish. Can I do that? We'll say this is public repository. Nice. And now I'm actually going to update my, I just copied that. I'm going to go back to Visual Studio. We're going to go back to packages. And so we have a reference here. Where does it say repo? It asked about that earlier. I could have sworn. I think, did it exclude it? Yeah, I was hoping to see like repository section here. Well, I think that's okay. I think that's still valid. Let's just do our npm run build again. That all works. Okay. Yep. So yeah, I just wanted to put in my package JSON something to remind me where this source code is located. So you can check out this source code at any time. Should be up in this GitHub website. Excellent. So I'll just say the next commit is add the repository. To the package JSON. Good enough. Let's see if that syncs up. All right, so far so good. Okay, I'm going to stop it here and we'll pick it up and start making this thing our own. All right, thank you. Hope you join me for the next one. Welcome back. Let's continue on. So at the moment, we've got this simple Elm application. Doesn't do much. It's basically a static web page, but it's built using Elm primitives. Let's open that up in the browser again. Once again, this is I have a plugin that has this shortcut built in for me. I'm sure you can figure out how to open it yourself. So I'm just opening that web page, and it's a good old Welcome to Dunder Mifflin website. So yeah, we can change that. Let's discuss the plan. I think we want this to be like Welcome to PokeTypes Battle Practice, or maybe just PokeTypes Battle. Yeah. Byline, defeat as many as you can in 30 seconds. That sounds good. Maybe we'll have a link to that type effectiveness chart, because one thing you've got to learn, what beats what. So we'll have a link back and then a nice old start button. Okay, that should be pretty easy to do. Let's dive in and make that change. So that's our first simple change. Let's open our source again. Let's go to our home page. And it's not Dunder Mifflin, it's, I think, PokeType Battle. Yeah. So, now, let's get rid of all this stuff and we'll just add in what we need. So, there's an H1, nice big old H1, says Welcome to PokeType Battle. Let's then add a paragraph underneath. So, and comma there. So, here's our paragraph. Now let's add some text. Defeat as many as you can in 30 seconds. Sweet. After the paragraph tag, I think we want to have our hyperlink to that Pinterest website. So I'll say, give me an anchor tab, bracket. I always do this. It's just kind of, I know that I'm going to need two lists after any kind of a HTML element. So I just stick it in and then I fill in the details. So for this, I know the text is going to be along the lines of click for Pokemon effectiveness chart. I don't think we're going to use that very often, but it's nice to have it. And let's add our href here. So href. So we're going to send them someplace. Where are we going to send them if they click on the link? We'll send them right here. So let's grab that hyperlink. I think that's the same for everyone in the world. Let's go back to code, paste that in, sounds good. And underneath this, I think I want another paragraph tag, but inside that paragraph, I'm going to stick a button. And I'm doing this because I want the button down underneath. And what will the text be? The text will be start. Cool. Let's see if that worked. Now, first of all, I need to build it. So npm run build. Then I open my web page. Excuse me, using my shortcut. Whatever browser I want. I meant the default browser. Let's see, does that look right? Looks right to me. Does our anchor tag work? And it does. Okay, not bad. So next up, we're going to start adding logic for when they click on the start button. But this is a good spot for a break, so hope you join me in the next one. Thank you. Welcome back. Okay, let's update our application to actually do something when you click the start button. And what I'm going to have it do is change states. So initially, this is the initial state. As soon as you click start, I can say, you know, we're in the started state. So the started state will display a different screen, and that's a good first step. So let's go to code and start making the changes. Now I can see right off the get-go that we are using, there's no runtime right now in this Elm application. We're just, you know, when I take a look at main, it's just a, you know, main is just a function that returns HTML. And how it does it is it calls the view, and it passes in, you know, a dummy model. And this is the HTML that gets displayed. So very simple, but it's not really the Elm runtime. We want to use one of the Elm runtimes. So they're all part of this package called browser. So if I go browser, browser, dot, and element. Now this is kind of important. By using auto-completion, it also adds the import up here. So you may see me type in stuff and auto-completing, and so it's adding imports for you. If you don't have an IDE that does that, then you have to manually add it yourself. But that worked for me. So element, what does it need? It needs this. I'm going to copy this. It needs a record that's got 4 members. One called init, another called view, update, and subscriptions. So let's just fill these in. Init, now this is the type declaration. I need to actually change it to an assignment. Init equals, and the simplest thing we could do is a lambda function. So here's a function that takes flags and returns a model and a command. And I'd like to get this a little close to what we need. So command, this is just going to be none. And excuse me, and model, I'm going to create our initial model up here. In fact, I'm going to say, let's do a couple things. So I'm going to say type model, type alias model. I want to create a type alias for a model. And I'm going to say initially it's an empty set. Right? Oops. There are special conventions that we need to do when it comes to some things. Okay, just all good. Type alias model. And in here, I want to pass in the initial model. So I'm going to go initial model equals this empty thing here. Now, I think model is probably going to contain state. So let's add that right away. I'm going to do another type here. I'm going to say type state, and state is going to be, let's see, type state, I'll say initial, so that's the initial state, or it might be the started state. Okay, so there's our 2 states. So that allows me to go into model and say a model is a record that has state, and state has to be one of the states. Cool. And so far so good. What's it complaining about? Oh, it's not used yet. Okay, we're going to be using it soon. It's all good. Initial model, well, actually, let's declare that one too. We can say initial model has to be a model. So initial model is a model. Okay, and so the initial model state is, we'll say initial. Okay, it's making progress. What's it complaining about here? Oh, we'll figure it out in a bit. Here's what I am going to do, though. I'm going to say this has to be initial model. Nice. So now we're using that initial model. So this is saying when the application is initialized, here's the model that we start with, and here's the first command that gets kicked off. Right? And by the way, flags can be passed in. Okay, so that's a good first step. Next, we need the view, then the update, and then subscriptions. So view needs to take a model and return HTML. And that's exactly what our existing function does. So let's just say view is equal to view. View is equal to our view function. And similarly, update, well, we're going to have to write this function. So let's just copy this. Update takes a message, and I'm reading this type declaration up here as a type, and it takes a message and a model, and it returns a tuple of containing a model. So we'll just return the model unchanged for starters, and the command of none. So update equals update now. So far so good. And then subscriptions. So subscriptions takes a model and returns a subscription. Yeah, I don't even think we're going to use subscriptions, but we declare it, and we can change it later if we need to. Okay, looking less red and ugly. So that's always a good sign. Now I do know it's going to complain about, like this is the original declaration. I'm going to get rid of that. And let's let it fill in an implied. Can we do that? No, I think this is causing us to, yeah, something wrong I've done here is not allowing the compiler to get far enough here to give us the implied type declaration. So let's just actually pay attention to our error. So what is it complaining? Well, maybe we'll just run the Elm compiler. Partway through parsing the record type, I got stuck here. Type alias model. Oh, good error messages. Yeah, of course. So there are some rules around, yeah, with records where the braces need to go, so on and so forth. So now it's a little better. And I think same thing here. Is that right? Maybe. Partway through, got stuck here. Oh, just like it says, hey dummy, this is supposed to be an equals, not a colon. Boom, nice errors. Okay, getting closer. And same thing here. Oh yeah, we forgot to, I forgot to do this one. Subscriptions equals subscriptions. And we keep doing this until we get rid of all the ugly red. Yes, so let's go back to, actually let's go here. We know it's going to be something along the lines of this. So I can say that main is a program. It needs flags, message, and model. Now we're not actually using flags, so I'm going to say I'm going to pass unit in for that. And now something's off with the body. Yes. So we can start being a little more specific. We're starting to use types here. I've already said, hey, this is the model I'm using. So let's actually change this to uppercase M. And lo and behold, yeah, it's looking okay. It's not going to do anything yet, but at least it compiles, I think. Let's see if it compiles, and it does. Excellent. Okay, so now let's circle back to why we're doing this whole thing. We want to add an on-click handler here. So I'm going to start typing on-click. And it's really important that I click here so it'll automatically do the import. And it did. Because I always forget where, what I have to import. So it imported that for us. Excellent. And our on-click handler, like what do you do with an on-click handler? Well, you send it a message. You send it a message. So we're going to start declaring, we're going to have a bunch of messages, different kinds of messages. So I'm going to say type message is equal to, and the only message we need to handle so far is start. Later we're going to add more and more types here. So at the moment, the one message that we have in the system is a message called start. So I'm going to add this here, start. Nice. And now the compiler's got our back. So if we go over here, it's like complaining. It's like something's off. Yes. So we're producing a highly typed message of that kind, and here it's not. So let's just change that to uppercase M. Excellent. Okay, and I think we're compiling again, and we are. So what do we want to do when we start? Okay, here's what I'm thinking. I'm thinking that we've got two states. We have the initial state and we have the started state. So we're going to want to transition from the initial state to the started state. Okay, we should be able to do that pretty easily. Now, let's see. Here's something I'd like to do, though. I'd like to display very different things once we're in those two states. So that affects this view up here. So I'm going to, I'm going to write another method, very similar to view, something that just takes a model. And I'm going to call this the game view. If I could type game view, I'm going to say game view takes a model, and it returns some HTML very similar to this here. So let's see. I'm going to have it return a div with some text in it, and the text is going to be text game has started. Okay, that works for me. So why did I do this? It's because I want to change what this does. So at the moment it just does this. I want it to look at the state. So this is kind of the main application state. So here's what I'm going to do. I'm going to say if model.state equals, and let's say, now here's a small thing. I like putting the small things first, followed by the big ones. So I'm actually going to do the game state first. So I'm going to say if it started. So if game state is started, then we're going to do something else. We're going to do something else. So here's our else. And I don't like the indentation there, so I'll just do that. Right. So what do I want to do? I want to display the game view. So if we've started, display the game view and pass it the model, and we'll let it figure out things. Cool. So yeah, so now we've got the ability to change. Initially, if your state is initial, which it is, we should see this. If the state changes to started, then we should see our game view, which is this thing here. Okay, I think we've got all the major pieces, except we haven't got a handler for, we don't know how to update when we get the start message. So that's what we need to add. So that will be in the update. So here's our update method. At the moment, we're totally ignoring the message. Okay, so now we can also start to be a little more specific. It's one of our messages. it's one of our models. It returns one of our models. And this also, actually we can just leave that one alone. Good. So, we're highly typed and we're able to say this. Case, and we're able to put a case statement in here. Case message of. So, the moment, the only message we have support for is one called started. And when we get that message, what are we going to do? Well, we're going to return a model and a command. Oh, I think I made a mistake somewhere. Let me just take a look. Start. Start's my message. Started is my state. So my message should be start. Yes, if someone passes the start message, here's what we're going to do. Okay, so we're returning a tuple with a model and a command. And we want to change the state of the model. So I'm going to say a record model, and let's modify one of the parameters. So we're going to say the state is equal to started. Nice. And I like to maybe break this onto a few lines. I think that makes a modicum of sense. So when we start, we're going to update our model and we're going to change the state to started. Now I'm also going to take this opportunity to highlight everything and bring up the command palette and just say format document, and we're just letting Elm do the indentation strategy that it likes because it's pretty good. Okay, yeah, that makes sense to me. You know what? This may actually work. So let's compile this. Let's go over here, and when I click the button, nope, nothing. Okay, what have I done wrong? Let's go back to Visual Studio Code. So let's just think about this again. So here's our initial state. Our initial model has got state equals initial. And if a command comes in, and if the command is start, then we update our model and we set our state to started. Looks right. What? Oh, did I compile yet? I thought I did. I'm sure I did. I compiled, but I haven't refreshed. So, sorry. I'm just going to reload this page. Okay, now we got the latest code. Now I click start. Game has started. Wonderful. And if we go, yeah, that's basically it. Okay. Thank you, and I hope to see you in the next one. Alright, welcome back. Okay, so far we're doing something. Let's go back to the application. There is one change I really would like to make now. So at the moment, if I go into index, I've got this hard-coded style sheet here. And really I'd like to have a CSS file with our styles in it. So I'm going to do that. Let's go over to dist. And we're going to go new, and I'll say main.css. Okay, and now under style, I can do, what is it again? It's more like this. So I can go link. I can say relationship is style sheet. And href equals main.css. Hey, it already found it. Nice. And I think that'll do it. So I'm going to take this, cut it out of here, and cut it all out of here. Go into CSS, paste it in here. And just to make sure it's actually working, I'm going to change the color to, we'll make it red. Okay. So that's a fairly straightforward change. The reason why I'm doing that is because I know as we build things out, I'm going to be storing a lot of stuff in style sheets. Well, a bit of stuff. We'll be defining a few classes for doing grid stuff. So let's just make sure this works. Do a quick build and open up the HTML. Open in, actually I can just refresh. I can do a refresh here. Reload page. Nice and red. So we can see that, yeah, that's working. Okay, good. That's a good ending point. I'm going to go back to our code. Maybe just commit this little change here. Start using CSS for styles. Awesome. Okay, see you in the next one. Welcome back. Okay, let's continue on. Now, next thing I want to do is let's start up Visual Studio Code, and I'd like to actually fix the color of this. So we just changed this to red just to prove that we were reading from a CSS file. So let's go back and actually change the color in here. And in fact, I'm going to go over to my mockup application, and I'm just going to grab the entire CSS that I used in my mockup, and I'm just going to paste it in here. That's not it. Let's do that again. Copy, paste. Much better. So I just brought over all of the CSS types, and we're going to use these in our application. So it's just good old-fashioned CSS, nothing. These are classes that we can reference from our Elm code. Simple as that. So now, well, let's just confirm if I build, do I get the updated color? So I'll reload my page. Yes, I do. I see the nice green here. Ooh, that's easier on the eyes. Okay. So what I'd like to do, I don't want to bore everyone with building everything from scratch. Since I have my mock-up, I'd like to pull over just the simple HTML part of the mock-up, and we can talk through it. Because it's time consuming to craft everything by hand. I'm just going to copy it over. But before we do that, actually let me bring my mock-up over here. One thing about the mock-up is it actually, it's a little more than just static HTML. I actually have a model that has things in it. And if we look at what's in the model, I think it makes sense. This is kind of the game state. You have an opponent. So here's what you're fighting against. And notice it's this thing called a PokeType. So that's kind of our next challenge, is we want to create this PokeType variable that defines, hey, this is the PokeType. Obviously, we're going to need a score, and eventually we're going to want the number of remaining seconds, right? Now, after you've done a round, we probably want to see a summary of what happened the previous round. I think that'll make sense in a bit. We always need kind of a running opponent list. So I've decided that what I'm going to do is I'm going to randomize all of the opponents, put it in the list, and it's basically, you take one and you throw it to the back. So, if I've done, you'll go through the entire list, then you'll go through it again if you're fast enough. So that's the idea. Let's get back to our model. So that's the opponent list. Now, we know that the idea is that for each opponent, we want to make sure that we have, counters. One of them needs to be strong, one of them needs to be neutral, and one of them needs to be weak, right? So that's our plan. We'll have some code that generates, what's the strong against type, what's the weak against type, what's the neutral against type. And then we'll have some code that actually randomizes those three and sticks them into this counter. Not counters, and I'm counting 1, 2, 3, but this is what I'm going to counter the attack with. So this is going to be the left Pokemon type, the center one, and then the right one. So that's the general idea. So let's start. Rather than copying this over and seeing ugly red because of all of this stuff, let's start by adding a PokeType. So I want to copy over some of the stuff from this PokeType file. So what are we going to do? Well, we're going to put this in a separate file, and we're going to reference it. So we're going to define this file called PokeTypes, and in it, one of the things I'm going to do is I'm going to define each of the PokeTypes. So fairy, steel, dark, dragon, yada yada. So where do we get this? Well, we got that from that web page. Yeah, we got it from that web page. We're going to reference that web page again in a moment. So let's start by grabbing this. One strange looking thing though is should never occur. So I decided that the application was a little easier to write if I had a special PokeType that shouldn't actually occur at runtime. And you'll see how I use that. This is questionable if I should do it this way, but I thought it made my application easier. So yeah, so let's just grab this. So we'll start by just copying over those PokeTypes. Oops, I need to go back to Visual Studio Code, and I need to do what? I need to open up this guy. Yes. So we got two copies of Visual Studio Code, one for our PokeType battle and the other for our mockup. I'm just copying some stuff over from the mockup to save us some time. So we need to create a new file here called PokeTypes Elm, and we'll just paste that in. So this is saying that a fairy is a PokeType, so a steel is a PokeType, dark is a PokeType, etc., etc. So we have all of these nicely typed types that we can use in our application. It's actually, I love it. It's great stuff. Next thing, I need to have, there's obviously a few things in addition to this that we want to be able to do. And one of them is we do need to be able to have a list of all of the PokeTypes. So that's the next thing we're going to copy over. Here's all the types, including a little note that, hey, the should never occur is not listed in all types, because this is basically a list of all valid types. I hope that makes sense. So let's add that in here. Okay, that looks pretty good. Maybe I'll go just a little deeper, and yeah, this one we're definitely going to need. Somehow, if we have a PokeType, we need to be able to convert it to the name of that PokeType. So that's what the getName function is going to do, is if you give it this type, it returns this name. Now, interestingly, it would be really nice, there's this nice little function I could have used instead of this big case statement. I could have said debug.toString, and I could have just given it a PokeType. But there's a problem. This debug.toString is only something that's available in debug. It's not available in production. So, long story short, we're going to do it this way, which is okay. Just kind of repetitive. But that's also why we put it in a big separate file. I hope you get why I'm copy pasting. I mean, this is saving us quite a bit of time. I did have to do all of this by hand. How I did it was I visited that website and it's just like, oh, I need a rock. Let's do rock. Let's do fire. Another thing we're going to need to have this appear the way we want it to is like the colors. What are the colors? So once again, we're going to have a function that you give it a PokeType and it'll return a string, which is basically the color. You'll notice that it's this hex-coded string. The way I got this, you can basically, yeah, there's lots of tools you can do for pulling a color. So let me just show you this. I'm going to use Snagit, and I'm going to go, hey Snagit, I want to grab this. Why am I doing this? So here I'm using a tool called Snagit, which is just the tool of my choice. You've probably got another tool that you could use for a color. So I'm just wanting to show you this feature right here. I can, oops, I can go here and just hover over a section. You know, I can click on here, and that sets the color. And then, oh, there's my hex code for that color. So that's one way of using a tool like Snagit to snag a color. So I was able to find colors that I like and say, yeah, here's what I want for grass, here's what I want for fairy, here's what I want for steel. And I just did that, and that was what we copied it. Have I copied this yet? No, I haven't copied this yet. That's what I'm going to copy. Just a second. Let's grab all these colors. Great. Nice. Okay, so our PokeTypes now exposes a few things. We have the various types. This is the most important thing. Then we have the list of all types, and then we have the something that can, if you give it a PokeType, it returns a string with the name. And then finally, if you give it a color, if you give it a PokeType, it gives you the color string back. So these are kind of some fairly obvious pieces that we need, especially if we're going to copy over that mock-up that I just did. So I'm going to go back to the mock-up. And one more thing, we're going to need that model. We're going to need to update the model. And yeah, let's do that. This is my mock-up. I'm going to go to my home page, and I'm going to search for model. So, wow. I can do better than that. Let's search for model. There it is. So, I'm going to grab this right away. So, I know eventually this is the kind of model that we want, right? So I'm going to grab that. I'm going to go to our model, and I'm going to update it, which should actually cause a bunch of errors. Yes, so we can already see some red, not too many errors. I think, what's the error? It's probably complaining because we probably don't have last round summary defined. But I got stuck here. Just curious what the error is. You know what? Before I read through this, I know I'm going to need last round summary. So this is an interesting one, actually. So this is a variable. It's a maybe variable. So initially it's going to be nothing, but then after you've done a round, we're going to populate the last round summary. So it may be nothing, or it may be a last round summary. So let's define last round summary. I'll go over here. Oh, here it is. So here's last round summary. Nice. Okay. So I still have that red here. Let's actually see what is complete. I do know that I also need to update the initial state. So I might as well do that before we try to figure out the error message. Let's steal the initial state from this thing here. Initial state. It's actually called initial model, I think. Initial model. There it is. Nice. And actually, this is still a very appropriate initial model, I think. So we're going to grab that. We're going to go in here. We're going to replace our initial model with this new one. And I still have something slightly wrong. You know what I bet it is? I bet you I haven't... PokeType, yeah. Let's autocomplete that. I think I need to import it. Yes. So I'm just going to autocomplete it. Haha. Maybe, maybe not. So let's go to the top here. I'm looking at the red things. You know, I'm just trying to spot the error message. And I can't really tell. So I'm going to make this a little bigger. Let's just run the build. And what's the first thing that it complains about? Oh, that's a dumb one. I didn't copy enough. So I can see, this, it's like, oh, I haven't even got the closing. Okay, well, that'll help. Yeah. And now I'm seeing, you can't find grass. Okay, so let's just go up here. So there's the PokeTypes. Let's run this again. So I think let's bring everything over from that class. That fixes up quite a bit. Game duration. Game duration is something we haven't defined yet. And that's going to be, let's say 30 for 30 seconds. You know what? I think it's compiling now. Let's just confirm that. And it is. Whew! Right, so we haven't done anything yet. We just kind of brought over some of the bits and pieces that I know we're going to need. So, yeah, let's take a look at that one more time. So here's our PokeTypes. Actually, I don't need to look at the PokeTypes again. Yeah, the important thing is we now have a bigger model, and it's got the last round summary. And yeah, it's got this new initial condition. So anyways, let's just confirm that it's still running. I'm going to go back here. We're going to reload page. And if I click here, actually we haven't changed the UI, so it should just give us the same old game as started. Alright, that's enough at this point. I know what I need to do next, but we're going to take a break and come back to it. We're going to steal some more code and start filling in the details here. Hope to join you soon. Welcome back. Okay, let's try to put something more interesting than just a div that says game has started. So the good news is we can actually steal from the mock-up that I made. This is just real simple HTML for the most part. But I'll talk through it to explain it. So yeah, why don't we just grab this entire game view. In the game view, down here we can see counter div. That's a reference to this code here. And I think that's all we need. So I'm going to copy that. And we're going to replace our game view with this one. And I see some syntax errors. Oh, interesting. I actually used debug toString. Actually, I should have used, I think it's called string.from int. Yeah, I should. That's better. That's what you should do. So there was a small thing wrong in my mock-up. Fixed. Okay. That seems to have copied over. Let's see if it still compiles. Come on. And it compiles. Okay. Let's reload the page here. Click start. Nice. Okay, so now it's starting. It's not doing actually it's kind of doing some right stuff, but yeah, it's starting up. Nothing happens when we click on anything. That's all stuff that we're going to get to, but basically it's there. So let's just talk through what we copied over before we move on to the next thing. So back to Visual Studio Code. Of course, if you understand all this, you can just skip right by. So this is not that difficult. So all we're doing is, anytime you want to, the game view, right? The game view, you pass in the model, and it's going to return HTML. What's the HTML? Well, it starts by going to the model and pulling out the three counters. We have a left counter, a center counter, and a right counter. And those are things that are referenced down here. At the very bottom of our HTML page, we have something that's on the left side, something's in the center, and something's on the right. So, yeah, so executing this basically returns the PokeType for the left side and the center and the right side. So that's how that all is working. Back up here again. Yeah, so we have a div, that's the game container. I wonder if I should actually just... no, this is pretty simple. I was thinking about bringing up the development tools and clicking on everything, but basically game container. Let's do this though. Let's go into the CSS, and the game container is basically saying, hey, this div is a grid, and this div is going to occupy the entire screen. And also, I'm putting, in this grid, the default grid gap is going to be 10 pixels, so give me 10 pixels around each grid item. And then finally, 10 pixel padding on the outside. So you can argue that maybe I should do it differently, but this was simple. Yeah. And going back here, oops, I don't need to go back here. In fact, I'm going to close the mock-up for now. Going back here, we then have some of the text. Actually, let me move it to the side here. There we go. So you can kind of see what's happening. This is our HTML. We got a div that says, hey, I'm laying things out in a grid. And in this very top grid here, so this is the title section. And if we take a look at the title section, actually it says I'm a single row and I'm 3 wide. I think that's what it does. You can look at it. And in this title section, we then start laying out some things. So I'm saying, hey, I want an H1 that's centered, and I want it to say PokeType battle. Okay. Then I want to display a score, and the score is just, well, whatever the current score is. And I also want to show under that the time remaining, and that's whatever the time remaining is. Under that, I'm switching to Flexbox, where, actually this is some stuff that's going to come up a little later. Okay, when we, so under time remaining is a section that we haven't hit yet. We're eventually going to want to be able to show, like, hey, do you want to play again when you hit the end of the game? So that's what this section is all about. And I do want to point out, you have to remember, with Elm, this is just code. So I'm able to say this is a div, this is a style, this is a style, and then I'm able to say, oh, I have an if statement. Just regular old Elm if. And in here I'm able to say, okay, in this case, display a button, else do this code. And what this code does says, hey, remember that thing called last round summary? If I've got a last round summary, display it. And what is it? It's a div, and it's centered, and it's got these characteristics. Otherwise, just display an empty div. So that's what I'm doing for this section down here. And we haven't played the game yet, so there is no last round summary. And we have to add all that logic soon. That's basically it. And then there's a little more of this, basically if we're done, display this. Otherwise, actually this is kind of important. I'll talk through this and then we'll move on. So this is for the bottom section. So we have an opponent, right? We have the opponent right here. And what do? We actually, opponent is, we get the name of it. Okay, and in fact this is kind of important, so let me just back up a second. So this div is for the opponent, right? And there's two things that kind of come from the model. One is the color. So, hey, the background color of this div is, we basically say, hey, whatever PokeType you are, get the color of it. So I call the get color on the PokeType, and it'll return that special color code. And that's why, actually, the reason why this is green and grass is because in our initial model we said, hey, start with grass. Why not? Then after that, we're going on. Inside this div we display the name, and it says opponent is whatever it is. So opponent is grass, and you'll notice like opponent is just text, and grass uses a class type name. So that's how we get the nice big white letters here. It's a CSS class. If we switch over to main.css and we look at type name, there it is. We said it's a 5M font size, and the color is white. That's how that works. And next we've got our 3 counters. And what we do here is we have some code that returns the div for each of the 3 of these. So this code, let's take a look at it. It takes a string and a PokeType and a model, and it returns HTML. Huh? Okay, it's not that hard. So here's the string. This basically says, these are the classes. Okay, so this is actually the class string. So each of these divs have a slightly different class. So this div here has got the class string versus1 in center. The middle one has got versus2 in center, and versus3 in center. And it won't be surprising if we look at versus1, 2, 3. There's probably a better way to do this, but this is just the way I did it. Versus1, 2, 3. It's basically, it's the grid setup. So we're saying, this one, they're all in the same row. They're all basically in this 4th row, and I want it to be a big row, so relative to everything else it's got a span of 4. And then I say, this first one is in column 1, and the second one is in column 2, and the third one is in column 3. So that's how we get our 3 columns laid out like that. Excellent. Let's go back to here. And that's basically it. So the bit of code we use here, since these are practically identical, I don't list out each one individually. Instead, I've got this function here that does the same thing. And what it's saying is, well, if we're not out of time, if we're actually playing, then we'll display a button there. Otherwise, we'll display an empty area. And like I said, but yeah, each one of these very similar to the top one. It's like, here's the color. So we, the PokeType got passed in, and based on that type, we look up the color, and then we also put the name here. Okay, I think that explains things. I hope so. And I think that's a good point to stop. So yeah, we've got some, it doesn't do anything yet, but it looks nice. It's very simple. And next up, we're going to start adding some logic to do all the things that we need to make an actual game out of this thing. So hope you join me in the next one. Take care. Oh, and before I go, I think I'll just save our point in time. So I've been doing this throughout, but I will mention. So this one is, let's see, brought over some basic brought over some basics HTML stuff for the game. Right, and that's kind of what by the way, this is kind of what I wanted to grab for my prototype, just this stuff. I didn't want to go through it by hand. The rest of this, I anticipate that we'll just, we'll actually go through it step by step. So, excellent. All saved up there. And I hope you join me for the next one. Thank you. All right, welcome back. So let's start making our application actually do something. I think the first thing I want to do is rotate through the list of opponents. So let's jump back to the source and let's look at those PokeTypes again. So this is a list of all the types. And kind of as a first step, I'd like to, start with something and just move through this list. Okay, so as you select a new opponent, we'll just grab the next thing off this list. And we also want this, that's exactly what we want to do. But I will mention one other thing. We don't want to stop at, I think there's 20 here. Basically, if you go through all of them, let's go through again. So that's the kind of thing that we're going to put in this next step. Okay, so I think when we click on these, because these are buttons, we'll have this rotate to the next opponent. So going back to the code one more time, let's take a look at what happens when we click on one of those counters. So here's where we have the counter div, and at the moment it's commented out. Cool. So this is saying, let's just uncomment it. So if the user clicks on one of the divs, then we will send a message to the runtime with the specific PokeType that was clicked on. Okay, that sounds good. So the next thing we need to do is add a message, counter with, and it's going to be parameterized on the PokeType. So we're going to go to our messages. Oh, it's right here. That was lucky. We're going to say I have a new message called counter with. And if this message is generated, we also need to know PokeType. Okay, that's pretty good. And here's an example of Elm having our back. So as soon as I typed this in and saved it, Elm says, hey, wait a second, you don't have that particular case covered. So when an update happens, if they pass us one of these new messages, you don't have it yet. So let's add a case for that. So let's say they counter with, and they of course give us a PokeType. So what do we need to do? Well, the bare minimum is we need to return a tuple that consists of a model and a command. So that should be enough to satisfy the compiler, and I don't see any ugly red, so I think it did. Now let's take a step back though and think about what we need to do. Let's look at the model for a second. So here's our initial model, and we're going to give it, we have this next opponent list. And what I'd like to do is anytime someone clicks on, a counter, we want to take the next opponent off this list, and we want to shove that into opponent. And then we want to have a new list here where the first opponent, like the head of the list, goes to the tail. So let's write a function that can do that for us. So given a list, return the head, and also return a copy of the list with the head on the tail. Hope that makes sense. That's what we're going to do. We're going to rotate our opponent. So let's create a new command, a new function called rotate opponents. Right, and let's give it a type declaration. So it'll be a list of PokeType. So given a list of PokeType, what's it going to return? It's going to return a tuple. So two things. It's going to return the PokeType, which was the item that was on the head of the list. And it'll also return us a new list where the item on the head is going to be on the tail. So that's a list of PokeType. Alright, so far so good. So let's actually implement this. So rotate opponent equals. Great. So we're going to start with a let statement. I want to get the head of our list. So I want to do list.head of our, oh, wait a second, I need to actually say, yeah, this method, this this function, you need to pass in PokeType. PokeTypes. There we go. So you pass in a list of the PokeTypes, right? Now that's the list that we're going to take the head of. And I'm just going to say let head equals. Okay, and once I got the head, I can do something with it. In fact, what I can do is we're going to return the head, and we're also going to return a list of PokeTypes. And we'll, let's just return this list. Now, this is not going to work. It's noticing something. So if we look at this, oh, this is a maybe of PokeType. So when you grab the head off of a list, you may or may not get an item. And why is that? It's because your list might be empty. And if it's empty, you don't know what, well, there's nothing to return. So the good news is that's not too hard for us to deal with. So we're going to wrap this in a case clause. And if there is something, which will happen, we'll return it. Otherwise, we'll return some special value that should never happen. Let's do that. So case of. So now we're saying, hey, go through this list, grab the head. And if we have an item, so if we have just PokeType, then that's what we're going to return. Cool. Otherwise, if it's nothing, well, what are we going to do in this case? Well, we'll just return should never occur. So that's one of the reasons why I kind of liked adding that extra element in. It makes it really easy to do something like this. We know that we have a list. We know that it has elements in it. So this should always occur, and this should never occur. Nice and simple. Okay. So this gives us the head of the list. Now, what about the list that we're going to return? Well, actually, for that, we want to get like the tail. So remember, a list, you grab the head, that's a single element, and the tail is everything else. And that's kind of the starting point for what we want. So I'm going to say tail is equal to, and I'm going to say list.tail, and we're going to pass in those PokeTypes again. All right, so we're just trying to get that tail. But once again, because this could be empty, if we hover over tail, it's like, oh, this is a maybe. This is a maybe. And it's like, actually, we know we're going to have something. So I'm going to wrap this in a case statement. I'm going to say case of, and there may be better ways to do this. This is just how I'm doing it. I think it makes sense. So we're expecting to get some PokeTypes back. And if that happens, just return that. And if we get nothing back, well, that's unexpected. I guess we could just return nothing. Why not? Or we could return, just return the, something went horribly wrong. Just return, oh, yeah, excuse me. I'm using the word PokeTypes too much. So, let's say just tail, return the tail. That's better. So, let's see. We're asking for the tail of the PokeTypes list, right? And if we get something back, if we get a tail back, that's what we're going to return. So this is a list of PokeTypes. Now, why am I getting this red thing here? I know why. It's because I'm using this. I think I know why. I think it's because I'm using that name here. So let's just say T instead of tail. That's better. So, yeah, I don't know if this makes sense. Here's our PokeTypes. We just want the tail of that list. So it should do this. But if this were to be empty, then just return the list. Yeah, that's good enough. It should never be empty, but we do need to, tell the software what to do in case that happens. So now, this is interesting. So now what we're going to return is, what was the head of that list, and also return another list called the tail. But in addition to the tail is everything except for the head, and we're going to take the head and we're going to add it to the end. I hope that makes sense. I need this operator instead. There we go. No, is that it? What is it? Oh, I remember. Actually, it is. This is a list, right? And I'm going to append another list to it, and the list will just consist of the head. That'll work. Whew. Okay. Looks useful. So now we've got this function. You give it a list of PokeTypes. It's going to pull one off the head, and then it's going to give us two things. It'll give us that PokeType, and also give us a new list where basically it'll rotate everything in there. That's why it's called rotate opponents. Now we can use this in here. So let's break this up. So model on one line, command on the next line, and the model, well, we're going to do a couple updates to the model. So first of all, let's use that fun let thing again. So we're going to say let and we're going to call our function. So we're going to say let new opponent and new opponent list is equal to a call to rotate opponents, and we're going to give it our model and next opponent list. Excellent. Okay, right, so we're calling our function. We're getting a tuple that consists of those two things, the new opponent and the new opponent list. And now we can update our model accordingly. We can say, hey, model, your new state is this. Your opponent is equal to the new opponent. And your, what's that member called? Is it next opponent list? That's what it's called. Your next opponent list is equal to the new opponent list. Okay, I think that might just do it. So let's give that a shot. Let's see if it compiles. Go back here. Oh, I'll just type it in. npm run build. Great. Now I can go over here and just do a reload page on this, and we'll start. Okay, so this kicks in as soon as I click something. So I'm expecting as soon as I click something, it should say fairy. And then when I click another thing, it should say, I forget the next one, but it's going to circulate through that list. That looks very familiar. And in fact, I'm going to type it enough that we can see that it's able to circle back, and it comes back to fairy, and then it goes to steel again. So it's a it's a rotating list of opponents. Hey, that's a good first step. In the next step, I think we'll randomize this list and we'll go through that. So thank you, and hope you join us for the next one. Welcome back. Okay, so we're now successfully cycling through our list of opponents. We go from one opponent to the next. And the next thing I'd like to do is, before we cycle through that list, let's randomize the list so that, at the moment when let's just demonstrate this. I'm going to reload. I'm expecting to say grass, because that's the default that got loaded. And then I'm expecting it'll say fairy. Do fairy, great. And then, is it dragon? Steel, that's right, steel's next. So it's just going through the list. Let's randomize the list so that you don't know the order. So how do we do that? Let's go to our code. And the first thing I need to mention is it's not as simple as calling a function and saying give me something random. Now the reason for that, very pure functional. In a pure functional language, you call something, and if you give it parameters A and B, you'll always get the same response back. So functional programs don't like side effects. Side effects have to be handled differently. But what we can do is we can send a command to the runtime to say, hey runtime, please generate a random number for me and send me back that random number. And when you think about that, that makes sense. It's like, oh, I'll send you a command, and the command says, give me something back random. You'll always get that. So you are getting back, exactly what you asked for. So let's do that. Let's make that change. Let's start by going to our initial model. Here we go. And here's our initial model, and here's our main, where we initialize everything. One thing you notice about the main is we start off with the initial model, and then we say, oh, and there's no command to process. Well, now we want to say, hey, here's the initial model, and here's a command that I want you to run. Let me just paste in from my sample, from my mock, the command that I think we want to run. So I would like to, when we start, give it the initial model and start the opponent selection. And this will send a message to the Elm runtime to randomize that list of opponents. So we can see right away we've got a bunch of red, some kind of errors. But these are pretty obvious. What's happening is, well, we don't actually have the Elm library for doing random stuff yet. So that's why this generate function is red. So the first thing I'm going to do is go Elm, and let's just get some commands here. Elm install is the command I want. Elm install. And if I just ask for help, it tells me, oh, here's a common one. So these are some of the common ones. JSON, HTTP, random. Let's install that random one. Boom. Yes, please update my JSON file for me. And you'll notice if we look at the changes, it added Elm random. Awesome. So as soon as we do that, let me just go to the top and import that. Import random, and we'll say exposing, and you can just give me everything. And that should take care of one of our errors. Yes, it gets rid of generate. So generate, we now know that this is coming from the Elm random library. Awesome. So two things left. The parameters to this function are excuse me, we need to tell it what message to bring back when it's done its randomization. Then this is basically the this is the randomization operation. Now you'll notice though, it's like, hey, we brought in the random library. What's happening here? Why don't we have random list shuffle? Actually, The random library that Elm has gives us things like, oh, generate a random number, generate something in this range. But it didn't have well, let's just do a quick Google and bring in the library support for this, for doing a shuffle. Shuffle is just like, shuffling a deck of cards. You give it a list, you shuffle it, it randomizes it, and it returns a list in random order. Same number of elements in, same number of elements out. So it's nice and predictable. But it's not built into the random library. It is indeed a library from, well, we'll see, a community library, I think. So let's just say Elm random list. And if we look up random list, yes, it's Elm community random extra. I'm actually going to copy this to my clipboard because this is the package, and actually, what is that? You'll see. When I do the import, I'll specify this and this. So let's go back to Visual Studio Code. And let's see if we can get rid of this ugly red message by doing Elm install. I'll paste that in. Oh, that's perfect. That's exactly what I want. Elm community random extra. Yes, please. Bring that in. Okay, so it brought in that library, and now we just have to do the appropriate import, which I think is just import random dot list. There we go. I'll bring them all in. Now going down here. Excellent. So this random generator has been imported and we can use it. Now the last thing we need to do is actually add this message. So we have a message called randomized opponents. And let's just go to our list of messages, which I think is close. Where is it? Messages. Let's just search for it. MSG. Come on, I know you. There it is. So now we have a third message type. And this message type is called randomized opponents. All right. Now this one's going to be parameterized by a list of PokeTypes. In other words, when this message gets processed, it's going to return a list of PokeTypes. So I'm going to say list PokeType. Okay, that looks about right. I think that's about right. Let's go back here. And now, of course, Elm has our back. It's saying, hey, dude, you don't have, well, if you read through here, it's going to say, hey, you don't have something for randomized opponents. So we can add that now. So we're going to add support for getting the randomized opponents message back. And it's going to give us a list of PokeTypes. And then we're going to do something. So just to see that I can make the compile messages all go away, I'm just going to do the simplest thing possible, which is return, a tuple consisting of the existing model and a command with none. And hopefully, when I save that, come on. I think there's no errors. Let's just do a quick compile. Elm, actually just npm run build. Opa! Okay, so it all compiled without error. That's excellent. But it's not doing the right thing yet. So let me just explain. Going back here, let's go to this. So this sends a message to a runtime and says, hey, I've got this list of types. Please do a random shuffle on it and then return that to me. And when you return it to me, it's going to come back in your randomized opponents. Okay, so it's going to send a message back saying, here's your list of randomized opponents. So we got that list back, but we're not doing anything with it yet. Not doing anything smart with it yet. So let's do that smart thing. It's going to be real simple, actually. Oh yeah, let's go to our update. Update. We were just there. I know. I'm sorry. I'm sorry for bouncing around, but this is how I think. So here we go. We're in our update. There's that new thing. Here's the simplest thing we could possibly do. Now we want to do the real thing. What's the real thing? Well, the real thing is to update the model. So we say, hey, model is a model, and I want you to go to the, actually it's going to be a lot like this. The next opponent list is going to be the list that it returns, the PokeTypes. Excellent. So, what's going to happen now is we didn't kind of prime the pump. So let me explain that for a second. We still start off with we're still starting off with opponent is grass. Okay, but once you click on the next thing, we should have a randomized list of opponents. So just to refresh our memory, previously when we started with grass and we went to fairy, then steel. Now from grass we should go to something random and something else. So let's give that a shot. So can we compile? Yes, we can. Okay, now we go back to our page and let's reload. So I'm expecting it'll start off with grass, and it does. Now I click on something else. Now I don't know what it's going to be. So if I click on it, steel. Then grass, then poison. And if I circulate through this list till I get to steel again, going through it, it should repeat. So we're back to steel, grass again. Do you see that? So it's a circular list. That's exactly what we wanted. Except, of course, we don't want it to always start with grass. So we're going to fix that up coming real soon. So thank you, and see you in the next video. Welcome back. Okay, next let's solve the problem where when I click start, it always starts with grass. There we go, it's always grass. And after thinking about it a bit, it's like, oh, there's a real simple way to address this. So let's go back to our code. Here's Visual Studio Code. And it's very similar to what we did with counter width. So when we did counter width, we wrote this function that does the rotate opponents. So what we want to do is when we get the response back, when we get our randomized opponents back, we're going to want to use this. We're going to want to use this function, and we're going to use it to, basically do the same thing we're doing up here, which makes sense. We're doing it for the first time. So I'm going to grab this. Right, so this gets called, this message, when this message is broadcast, we get these PokeTypes. And that's actually what we want to randomize, that we want to rotate through. So I'm going to pass PokeTypes into our rotate opponents. Boom. Okay, so what'll this do? This will basically, hey, here's our randomized list. Take the top one, take the one off the head, and then rotate it and take the head and put it to the tail, just like we did earlier. Okay, that's looking pretty good. Oh, and actually we can steal this bit too. It's going to be identical. So I'll just copy this, paste this over here. And need a comma here. Awesome. I think that's it. So when we get our randomized list of opponents back, rather than just stuffing it into the opponent, the next opponent's list, we're going to take the head and we're going to make that the next opponent, and then we're going to rotate the list, and whatever the rotated list is going to become the next opponent list. So I think that should work just fine. Let's build this. Let's go over here, refresh our page, and then with luck, if we click start, it won't say grass, and it doesn't. Now it says dragon. Now, if we go through this, let's go through real quick. It should rotate. You should go through all the types and eventually arrive back at dragon. So let's memorize the first three. Dragon, psychic, ghost. So that's going to rotate. And there's grass, by the way. So that's good. We're finally back at dragon, psychic, ghost. Okay, it's all working. So that was an easy one. Hope you join me for the next one. Welcome back. Okay, let's continue on. First, a quick recap. So we've got our opponent selection working fine. As I go from one thing to the next, we have our next opponent. So for any opponent, so for example, this is rock. We need to determine a type. We need to determine something that it's weak against, something that it's strong against, and something that it's neither weak nor strong, so it's neutral against. So that's the plan. So let's flip over to our code. Boop. Yes, and here's the general plan. So after we've determined the opponent, we're going to then do something to choose another, something that's strong against, something that it's weak against, and something that it's neutral against. So how do we know what it's strong against, weak against, neutral against? That brings us back to that original chart. So I'm just going to reload this page because we happen to have the Pokemon type effectiveness chart right here. Right? So this tells us for any type, like grass, well, it's strong against water, ground, and rock. And it's weak against bug, flying, poison, ice, fire, etc. So in other words, for any type, there's an array of types, one that it's strong against and one that it's weak against. Cool. Now I happen to have already in my mock-up, I've already visited, each one of these. So there's grass, here's grass, and grass is weak against fire, ice, poison, flying, and bug. Right? So that's this nice simple stuff here. So I'm going to grab this rather than making you watch me type each one of these in one at a time. We're just going to grab this, we're going to copy it, and we're going to go into our code, which is over here, and we're going to go into our PokeTypes, and we're just going to paste that into the bottom. So now we've got this nice function that we can call, and we can say, hey, this type, tell me what it's weak against. So you call this with the type, and it'll return a list of the things that it's weak against. And we can use that to pick, we can pick one of those using our randomization stuff. So let's start doing that. So going back to our homepage stuff, and what kicks us all off? Well, after we've done our opponent selection, that's when we can start picking what we're weak against, neutral against, and strong against. And by the way, the final step is going to be just to randomize those three things, and basically take something strong, weak, and neutral, and just shuffle that array. And that's what we'll do to fill in the counters. So we don't know. This will be the order on screen. This will be left, center, right. And we don't know if this is strong against, weak against. We just know that it's a type, and that's perfect. So let's go to our update where we fill in the opponent, and let's get it to, after filling in the opponent, start the random selection of something that we're weak against. That works. So that would be in update, which I think is down here. Yes, it is. Right, so here's where we got the message back that says, hey, I've given you a random opponent, right? So after updating the model, we're going to do one of those generate commands to generate the weak against. Okay, let's actually go visit. Let's do our command first. So over here, right? Yeah, the command's going to be, oh, actually, before I do that, let's look at let's go to Elm, and we're going to say Elm list, and basically we want to be able to choose something at random from a list, right? So list selection, random list, this is what I want. So in the Elm community package, so this isn't built into the standard random. This is a bunch of extensions that make, working with lists, random lists, and stuff like that extra easy. So earlier we used the shuffle to, shuffle up a list. Now we're going to pull something at random from the list. So that's what the choose operator does, choose. So with choose, we give it a list, and what'll it return? Well, it will return an item at random, okay, but it's got to be a maybe. And the reason why it's got to be a maybe is because if the list is empty, it has to return something. So yeah, so this is going to return, it's going to have an interesting signature. It's going to return a maybe, and it's also going to return a list of things with that element omitted. So, it's basically, if it's a deck of cards, it'll return one at random, and then it'll return a list containing the other 51 cards. Cool. We don't need this, but it's part of the signature, so we need to plan for it. Yeah. So, back to our source. Bum, bum, bum. So we know that we're going to have a message called, let's see, randomized weak opponent. Let me just check something here. Actually, randomized, let's call it randomized weak against. Yeah, okay. And this needs to be parameterized, and we already saw the signature. We know that it's going to be a maybe, and we know that it's going to be a maybe of a PokeType, and it's also going to be a list of the remaining PokeTypes. Okay, that looks okay. And now Elm's got our back again. It's saying, hey, you've got a missing case here. You're going to need to support that. So, we haven't even done the random generation yet. But we know the random generation, something's going to come back. So let's process the message first. Randomize weak against. Well, we know that we're going to get I'll call it a maybe PokeType. And then the list of remaining PokeTypes. And I could say, remaining. But it's convention, if you got a parameter being passed to you that you don't need, you can just put an underscore there. So that's what I'm going to do. I think I might need to surround it in parentheses. Not 100% sure. Oh, maybe not. Oh, excuse me. So now let's pull out that PokeType action, because we know that we are going to have one, and if we don't have one, well, we still have something we can do. So I'm going to say I'm going to say PokeType equals. Let's call it PokeType. Yeah, that's right. PokeType equals case, maybe PokeType of. So in one case we have something, so I'll say PT for PokeType, and that's what we're going to return. So if it actually is able to pull one out, that's what's going to get used. Otherwise, we need to cover the nothing case. And in this case, we can actually use that should never occur. So this is that special PokeType that we just wanted to add for things just like this. So this should never actually happen. And if it does, we know that we have an error and we'll have to fix our program logic. Might be a better way to do this, but works enough for me. So now that we got that, let's say in, and we can start using that PokeTypes. And now, just a reminder, we need to return a model and a command. Right? So syntactically, I see no red spots. That's good. Now the model, actually, in this case, we need to update it. So we use our record syntax to say it's the previous model, but we're going to say that the weak against is equal to the PokeType that we determined above. Excellent. Okay, that looks pretty good, except for the indentation. Yeah, that looks pretty good. Super. Okay. Now we actually need to do that the random command here. So when the opponent is randomized, we then need to pick. We need to, let's see. We need to first have a list of things that we're weak against, and then pick one at random. So I'm going to put the weak against stuff here. I'm going to say weak against list is equal to list weak against is our special function that we wrote, remember? And I need to say it's for our new opponent. Cool. So whatever our new opponent is, we're going to list its weaknesses, and this gives it a list. Now we can say this command here is generate is one of those generate statements. So generate this message, and the randomizer that we're going to use here is random dot, do I need to go back to the docs? Random list choose. That looks right. Let's go back to code. So I think it's just random list choose, and we need to give it a list. So we'll give it this list here. Something's not quite right. Oh yeah, this is ringing a bell actually. Okay, so the Elm compiler is smarter than me, and it noticed something. It noticed that this is highly, do you see capital M message, lowercase m? This is a specific message type versus this is a unbound message type. So something about what we've done here means that we should probably declare that we're using specific message types. So I'm going to go, I think it's as simple as going up here. Yes, and changing that capital M. So once again, Elm compiler, much smarter than I am, because I'm even having a hard time explaining that, let alone understanding it. Okay, are we compiling? Yes, we are. Awesome. Okay. Yeah. Let's do one more thing, just so that we can see the result. I'm going to say, yeah. What am I saying? I think I'm going to go back to the model, just so we can see what we're doing. Okay. I'm just thinking about this right here, updating counter width. So as a temporary measure, what I'm going to do is this. Not only will we update the weak against, but we'll also update the counter width, and I'll put the weak against in this spot here. And let's see. Actually, sorry, no, I need to, it's PokeType. And in fact, just for readability, I'll just say this is the weak against PokeType. No, I think it's just fine to say PokeType. My mistake, I'm just thinking about just trying to maintain readability here. Anyone, as soon as they see PokeType, they'll look up here. Oh, I see what's going on. So I think we don't gain much by calling weak against PokeType. Okay. Cool. Now the reason why I did this is because in theory, once this completes, we should always have something that we're weak against in this left position. Okay, let's build that. Let's go back to our application. Oh, well, let's go do it this way. We'll click on index and open in default browser. Okay. Bang. Oh, look at that. So rock is weak against water. Psychic is weak against water, apparently. Oh, something's not quite right. Yeah, something's not quite right, but it's a step in the right direction. So let's see. List weak against. I bet you we're not actually passing, it's just a guess. I do have a guess. So let's go back to here. Let's look for this. Okay. Oh, let's see. Well, off the top of my head, I can't see what's going wrong, but this is an opportune time to do a little debugging. So, tell you what, let's take a break, and then we're going to add a log statement in here, debugging log statement, and we're going to try to figure what's going on. But I'm going to take a quick break, grab a coffee, and hope to see you soon in the next one. Thanks.